All right, geometry class, this is lesson 7.3. And one thing about this lesson is that there is a little bit of to write actually in terms of notes. Notes can be a little lengthy at times and the problems can be a little bit long at times. So again, if you need to pause the video, first write the problem out and then hit play so you can see how I'm working it out. And then you can go about it that way, okay? I just think that'd be the best way to go about it. Okay, so we're going to go ahead and start. This is triangle similarity 7.3. Now I want you to start off by taking a look at this right here. Basically it says, do you see a difference? So the stuff on the left, we've done that already. Remember all the angle, side, SAS. What's another one that we missed? I know hypotenuse leg, HL was another one. I'm leaving one out on purpose because hopefully you'll remember it. But all the stuff on the left side over here, if we notice, everything over here on the left side is stuff that deals with one key word here. Hopefully you can see what the key word is. Key word here being congruence, congruence, congruence. And so far, what have we been learning about in this chapter? And if you notice over here, what's on the right side, it's basically what we've been learning this chapter. It's everything having to do with similarity. The similarity, the similarity. So there's three similarities right there. And so this lesson actually is going to deal with stuff that we've learned in the past already with the angle, with the side, and with the side. But instead of dealing with congruent stuff, now we're dealing with similar stuff instead. But it still works the same exact way. If you remember what angle is, and if you remember what side is, and side is, then it's exactly the same way. Okay? The only difference is, if you notice down here, we have two similar triangles instead of two identical triangles that are congruent. Okay, so let's go ahead and move on. So 7.3, triangle similarity. And again, we're dealing with angle, side, and side, angle, side, as it's right up here. So go ahead and write down your heading. I'm going to go a little at a time here so you don't go way too ahead of me. So it says, what does it mean to be similar? Now, hopefully by now you started thinking, well, yeah, from the last lesson, kind of saw that similar shapes, just basically, they look like they could be the same, but one's usually bigger than the other. And that's kind of what being similar means. Okay, so we're going to take a look at the first theorem here. And the first one says, for angle similarity, and I have a few fill in the blanks here that I need to fill in, okay? If two angles, that's an angle symbol, if two angles of one triangle are congruent, I remember what the symbol for congruent was, are congruent with the little wavy thing on top. If two angles of one triangle are congruent to two angles, I should probably put a little s after it, right, for angles. If two angles of another triangle, then the triangles are similar, okay? So basically, guess what? If you have two triangles, like the ones you see right here, over here, this one and this one, if you have two triangles and they kind of look like they could be similar, well, you can prove if they're similar if you can match up two pairs of angles that are congruent. And I'm going to go ahead and use the symbols, like these two, and I suppose that these top two, one right here and one right here. If all you're given is a picture with two triangles, and you see that they have matching angles, then right away you can tell me, Mr. Puebla, these are similar because of angle. And that's it. Okay, so we're going to take a look at an example right here. And I thought I had it here, so I'm not sure where exactly it's at. Let me see if I look somewhere around here. Let me see if it'll show. And of course, having technical difficulties. Let's do fading and see if it works. All right, guys, we're back. I had minor technical difficulties, so I had to reset this thing. But I'm back at example 1, and here's your problem. So go ahead and pause if you need to, and copy down the problem that you have there. Okay, so the question is, are they similar? Okay, now obviously this is going to tie into the last little theorem that I just talked to you about, which was angle-angle similarity. And, well, let's take a look at it. We have two triangles. We have a triangle ABC and a triangle DEF. And obviously I have one angle right there, angle A. And I have angle, let's see, what else do I have? Well, nothing matches up so far. The only thing that really matches is, if you notice, the right angle. There's one angle. Now guess what? As long as you can prove to me that they have another angle that's similar, then you can use angle-angle similarity and basically say they're similar. Well, hopefully you remember what the triangles add up to. 43 plus 90, and then what does that give you? So that's going to be 100 and, what is that? 33. And we're going to subtract that from 180. So 133 minus 180, you should have 47. So let me write down 47 right here for the missing angle. Okay, because I did minus 180 in my head. In my head, I didn't use calculator. And so that's 47. So guess what? Look, I already have two angles that match. I don't even have to find what this missing angle is over here on this side. Although I could, and I bet you that if I did 47 plus 90 minus 180, I would also get 43. So really, I have three angles that match up. I only need two, though. So I'm just going to say that this one and this one also match. So yes, these are similar triangles. So triangle, I'm going to just write down triangle A, B, C. Oh, I should be using the similar. So let's use similar. I'll use this. Similar. That's really big. Triangle ABC is similar to triangle DEF. Okay, and that one's done. That's it. That's all I need you to tell me. Let's go to the next one. Side-side similarity. Side-side similarity, or SSS. Okay, so in this one it says, if three sides are proportional to another triangle, then the triangles are congruent, or are similar, I'm sorry. So basically this is saying that if you have three sides on one triangle that all match up with another three sides of another one and they're all proportional, then you have a triangle that's pretty much congruent, similar. So, for example, I'm going to go ahead and label these DEF and then ABC. And I'm going to say that, let's say from A to B, it's, we'll say this is 10. And we'll say that D to F, E over here, I'm sorry, is 5. And let's just say that the A to C is 20. So we'll say D to F is 10. And then we'll say B to C is 4 here. And over here, E to F is 2. Okay. Now, I don't need any angles for this, right? Because the side is basically saying, are all the sides proportional? So let's take a look at this, obviously. Is this side right here, AB, proportional to DE? And is the same thing for BC? Is it the same ratio from BC to EF, maybe? And also, is it the same from AC as it is from D to F? Well, let me just write the ratios, because like it's kind of like what we did in the last few lessons. Let me set up. I have 5 to 10. It doesn't matter which order you put it in. I'm going to do 5 first and 10 right there, 5 and 10. And then I'm going to do my other ratio is 10 to 20, 10 to 20 right here. And then the last one is 2 to 4, 2 to 4. Now, do all these have similar ratios? So we all know, let's see, this first one, really, if I reduce it, that's 1/2. The next one, if I reduce it, 1/2. The next one, if I reduce it, 1/2. They're all 1/2 ratios. So guess what? You can basically say, yes, they're all proportional to each other. Therefore, it's similar. Now take a look at side angle side. Okay, just like it implies, it says if you have two sides that match up and an angle that's included that are all similar, then the whole thing is basically similar. So let's take a look. If two sides are proportional to another triangle, so here's what it's saying. Like this side, and then I'm going to say also this side and this side. Remember, I only need two sides. If those are proportional, and remember what proportional means. Proportional means, do they have that same ratio? So for example, is 8 and 24, and then let's say that the green ones are, let's say they're 3 and, would that have to be a 9? So if I was to say, okay, well, let me check if these are proportional. Well, again, you would do your ratio. And the ratio here is 1/2. I'm sorry, not 1/2. What is it? 1/3. And then let's try the other one right here, the 3/9. Reduce that. That's 1/3. So guess what? Oh, wrong one. So you have 1/3 there, 1/3 there. Same ratio. Okay, so they're proportional. So I already met the first part right here. If two sides are proportional to one another, to another triangle. Now here it says, and the included angle, this I'm missing in the angle right here. And the included angles are, what do you think it means? Congruent, because they have to be exactly the same, okay? Then the triangles are similar. So what does the included angle mean? And if you remember what the included angle, where that goes, I hope you know that it's the angle that's right between the two lines that we're talking about. So if we're talking about these two line segments here, then I know for a fact that I'm talking about this angle right here. And over here, it's going to be the same one right in here. So this theorem says that not only do these yellow, yellow, and green, green pieces have to be proportional, but the angle in here in between them has to be the same. If you know that all this information is the same for two triangles, then you can tell me that they're similar, okay? Again, if you're having a hard time or you need to rehear it, write it down maybe first and then rewind it and hear it again without writing anything, so you're just watching the video. Okay, so here's what you're going to do with this problem. I need you to tell me, how do you know that this is similar? So you're going to use one of the three theorems that we just talked about. You're either going to use angle, angle, or you're going to use side, 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 or side, angle, side. Well, let's take a look at what we have here. We have obviously two triangles. If you notice, there's one right here, the smaller one, and it looks like there's a bigger one right here. So they tell you the order that the letters go in right here, okay? You have an order right here. Now, give me one sec. All right, guys, I had to take a little break. Good old custodian Robert came in and vacuumed. All right, let's go back to this. So we're actually, let me go right back to this. We're on this one right here, example 2. So disregard this one down here for right now, okay? Let's pay attention up here to this one. So if you need to copy it down, pause it, copy it. Now it says verify that TXU is similar to VXW. Okay, so now I'm going to use all three theorems that I have so far. And I have, remember, let me just jot them down up here. I have angle, angle. I have side, angle, side. And I have side, side, side. I don't think they were in that order, but those are the three. Now let's take a look at what you have over here. Well, it looks like they give you a side here and a side here, and a side here and a side here. Now, to use this side, 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 I have to have three sides. Now, I only have two pairs that match up with two pairs over here. A pair there and a pair there, so I can't use that. That's a no-no. Let's look at angle, angle. Do they even give me any angles to begin with? Like, do I even know if T, this one right here, is the same as V? There is no way for me to even know that those are, because they didn't even mark it. So I can't say that. And then I don't even know if U is the same as W because, again, there's nothing there that shows me that they are the same. So there's no way I can use angle. But how about this one right here? There's two sides. There's two sides. Well, I got two sides there, and that looks like I need an angle. That's all I need missing. Now, where do you know an angle exists here that actually they both share that are the same, and that my cursor is flying around, obviously, because it's there for a reason. And I hope you know right here that TXU, this one right here, is the same as WXV. What property is that? Just by chance, see if you remember what that is. And I hope you remember what that definition is right there. Those are vertical angles, okay? So this is the same as this one. And, well, let's just check if this 12 matches a 16. Reduce that by what? 4? It's going to be 3 over 4. Okay, well, that one's 3/4. Let's check the other one. Let's check 15 and 20. I'm going to write it right down here. 15 and 20. Let's see what the ratio is for this one. Divide by 5, that's 3/4. Okay, that works. That works. So guess what? They have the same ratios, and the angles are the same. So I can say that this is similar because of side, angle, side, or SAS, right? SAS. So side, angle, side. Okay, so there we go. That's all you did. You just proved that. You can say that if you needed to write it out, you could say, oh, TX, side TX is proportional to, what was it? XV. And we could say then, what else did we use? We used UX was proportional to XW. And we said that angle, what else? What angle TXU? Angle TXU was congruent to angle WXV. Okay. So basically all this is your support, but you also did support it here too because you proved the ratios were these are rational. And then you just told me side, angle, side. Let's go to the next one. Are they similar? Okay, so again, let's use the three things that we have. We have angle, angle. We have side, 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 and side, angle, side. Now, just by looking at these, which one do you think is probably going to be the most obvious one we got to use here? And I hope you're not saying angle, angle, because I don't see any angles in there. I do see a ton of sides that are similar. So I'm going to say, let's try side, side, side here. I don't think it's angle, angle. I don't think it's side, angle, side, because there's no angles in here. So side, side, side. Well, let's match them up. Looks like I have 6, 9, 12 in that order. Small, medium, large. Small, medium, large. So let's set them up that way. I'm going to set them up just the same way. Small, small, small to small. So looks like I have a 6 and a 12. And then I have a 9 and an 18. And then I have a 12 and a 24. Okay, let's do the ratios for these, reduce them, see if they have the same one. Yep, they all have the same ratio. Therefore, I can say that these are similar because of side, side, side. And that's it. Let's move on. I think we have one more. Explain why ABE is similar to ACD. And then it says to find CD. Okay, so I need you to tell me why is it that this small triangle in here is similar to this bigger triangle here? Like, what theorem can you use? Can we use side, side, side? Can we use angle, angle? Can we use side, angle, side? Well, what information do we have already here that they share? And I bet you can probably spot it here, but if not, then I'm going to help you out a bit. I hope you can spot that. Well, look, they have matching right angles. Match, match. Those two match. Now, guess what? If I could just find one more angle that they have similar, then you're done. So I hope you can see that if I move, let me just move. See what I'm moving here? I'm moving this bigger triangle here. I'm just going to move this angle here because I'm more interested in this angle right here in this corner. Look at that angle right there. And now let me pull the smaller triangle right here. Listen, 1, 2, 3. Through the power of magic and computer technology, I'm going to break out that angle. There's that angle. Okay? Guess what those angles are? And I hope you don't say that one of them is smaller than the other, because if I slide them right onto the other one, they're both identical. Okay? So these are identical angles. So guess what? I have another pair of identical angles right in here. So this small triangle and this big triangle are similar because of angle, angle, because they each share two same angles. Therefore, they're similar. Now, the question's also asking, find CD. Find this one over here. Okay, well, you should remember from the last lesson that you can set up proportions here. Okay, we can say that x is to 5 as now I'm not going to say 3 is to 9. That's not true. So let me see if you can figure out what should go there instead of me saying 3 to 9. X is to 5 as something is to something. Okay, x is to 5 as something is to something. X is the big one, 5 is the smaller one. X is to 5 as the big one. What's the big one at right here? 9 and 3? I hope you've said it. It's 12. 12 is to, what's the small one? 9. Now you could have written it the other way. There's tons of ways to write this, guys. You could have written it, now let me get these out of the way because they're bugging me now. You could have written it as, let's do it backwards. What if you had done 5 is to x as 9 is to 12? That would have worked the same way. You could have even done something like 9 is to 5 as 3. Oh, you can't say 3. 9 is to 5. 9 is to 5 as the whole thing. 12 is to x. That would have worked too. I kind of prefer this one over here. They all work, believe me. 5 times 12 here, we should have 60 equals 9x. Divide by 9. What do you get? Are you going to make me do math again in my head, or should I bust out the calculator that I don't have in front of me right now as I'm doing this? 6.66666. So you should have x is 6.6 with the bar. Okay, and that's it. So this one's done, guys. That was basically the lesson. Your job is going to be on a test to tell me what theorem can you use to prove they're similar. Is it side, angle, side, angle, 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 or side, angle, side, 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 side? One of those three. Okay, based on what picture I give you. That's going to be your task. Now, if you had any questions, make sure you write down little stars next to it or notes so I know what you need help with. Okay, I do have some extra problems we're going to go through in class on whiteboards for more examples if you need more help with them. Okay, and that seems to be it. Okay, we'll do those tomorrow. And that's it.